Since every function transforms changes in independent variable to corresponding changes in dependent variable, therefore, the rate of change of dependent variable per unit change in independent variable is called gradient or slope of the function. Since functions occur either in the form of graphs or in the form of table of values or in the form of equations, so we will find slope of functions in all three different forms. Let's first find slope of the function in the graphical form. For this purpose, this graph O to A to B, B to C consists of three different segments, and we will find slope of each segment separately. Let's find slope of segment OA. Slope of segment OA. Slope of segment OA is equal to change in the dependent variable divided by change in the independent variable. So while moving from O to A, how much change has occurred in the dependent variable? The dependent variable is 0 for O and 50 for A. Therefore, this change is equal to 50 minus 0. And how much is change in the independent variable? That is from 0 to 10. So this change is from 10 minus 0. By the way, this is the time which changes along horizontal axis, and distance is the quantity that is changing along y-axis. Therefore, this is equal to 50 over 10, and this will be equal to 5. If distance is measured in meters and time is measured in seconds, then this slope of segment OA would be equal to 5 meters per second. The units suggest that we are talking about the speed. So you can see that in this case, slope of segment OA in fact gives us speed. Now let's find out slope of segment AB. Slope of segment AB. While moving from A to B, how much is the change that occurred along y-axis? Both A and B are at the same height, therefore there is no change. For B it's 50 and for A it's 50. So therefore this is 50 minus 50. Always if you are moving from A to B, then y value of B minus y value of A divided by x value of B minus x value of A. So this will be 20 minus 10. 20 minus 10, and therefore this will be 0 over 10, and the slope would be equal to 0. For slope of BC, slope of segment BC is starting point is B, end point is C. So y value of C, which is 0, minus y value of B, which is 50, divided by x value of C, which is 35, minus x value of B, which is 20. So therefore the slope for segment BC is equal to minus 50 over 15, which is in fact equal to minus 3.33, and again this is meter per second. So this is slope of BC. Now if we were given a function in the form of table of values, so let's do that. If function is given, as table of values, so let's assume here x is the independent variable and its value changes from 5 to 10, 10 to 15, 15 to 20, 20 to 25, and 25 to 30. And y being the dependent variable, its values change from 14 to 17 to 20 to 23 to 26 and to 29. It's very important that you are able to make a distinction between dependent variable and independent variable, because slope will be equal to, slope is equal to change in dependent variable divided by change in independent variable. So if you are unable to make the distinction between dependent variable and independent variable, then you might end up having a wrong value for the slope. Here x is independent variable and y is the dependent variable. Usually time is independent variable and whatever else is given, but we have done a lesson for dependent and independent variables. Please consult whatever concept of independent and dependent variable is taught in that lesson. So here y is the dependent variable. So let's see how y is changing. While moving from 14 to 17, there is a change of +3, and this +3 is the change throughout. For equal changes, this is also +5, and if values of x or y were decreasing, we will write minus instead of plus. So let's label all these increments +5, +5, and +5 here, and you can see that for equal change in independent variable, there is equal change in dependent variable. So it doesn't matter whichever 2 points you take, you are going to have change in dependent variable for any 2 points. This is 3/5, which is slope. But for linear function, this must be a constant. If x and y table is representing a linear relationship or a linear function, then remember that for equal change in independent variable, there will be always an equal change in the values of dependent variable. So that is an identification for a function to be linear. If this function was not linear, then for equal changes in the values of x, there will be unequal changes in the values of y. And now the last case, if function is represented by equation, and we will consider the case here. A quick example is 2x plus 3y minus 10 equal to 0 is given equation given equation of straight line, find the slope. Find slope. So the procedure for this is we are going to isolate y. The step would be, step 1 is isolate y. How we can isolate y? By moving all the terms independent of y from left side to the right side of y. And if we move all terms independent of y from left side to the right side, we are left with 3y equal to minus 2x and then plus 10. And because we want to isolate y, if we want to isolate y, then we definitely have to move this 3 from left side as a coefficient of y to the other side. And for that purpose, we are going to divide both sides by 3, because our objective is to isolate y. Nothing should be left on the left side without y. So if we divide both sides by 3, then this would be 3y divided by 3 equal to minus 2x plus 10 over 3, and we have y equal to minus 2 over 3x plus 10 over 3. And here slope is coefficient of independent variable. Now coefficient of independent variable is slope of line. And what is the slope here? Slope which is represented by m, slope of line which is represented by m, is equal to minus 2 over 3.